Hi everybody, hi. Okay, hopefully before you watch this, you have looked at the Khan Academy. I sent that link to you to learn about limits. These are really simple, as is everything with calculus. The calculus is simple, the algebra is the hard part. So that's the part I want to make sure that we go over. And also that you understand that the word approach and approaches is the important part for this. Because, for instance, if I have this kind of a function, and I say, okay, what is the limit as x goes to negative 1? Well, you can see if I put a negative 1 in here, negative 1 with parentheses squared, 1 minus 1, that'd be 0. And negative 1 plus 1 would be 0, and 0 over 0 is undefined. But that's if I let x actually equal that number. Now, what I can do with this is I can simplify it just using basic factoring techniques. Remember, this is a difference of perfect squares. So we have x plus 1, x minus 1. That's how that factors. And then down here we have our x plus 1. I want to point out to you, anytime that you have a binomial and a fraction, throw parentheses around it. It makes it much easier to see what you have. So now I can see, since it's fully factored, I can reduce here. Notice I can't reduce over here, remember? You can only reduce when things are being multiplied, not whenever they're added or subtracted, okay? So whole factors, things that are being multiplied, can cancel. Okay, so this gives me the limit as x goes to negative 1 of x minus 1. Now, I can let x actually equal negative 1, and it gives me negative 2. So that tells me that as x gets closer and closer to negative 1, okay, negative 0.99999, that kind of thing, it's going to approach negative 2. Now there, I just realized I have the air conditioner on and that's probably making a very loud hum. Sorry. Let me turn that off. Unfortunately, it's so hot. Okay, hopefully that wasn't too annoying for you guys. Okay, so I sent a link to CUDA software, which that's kind of a misnomer, you know. I don't know why it has the software name, because you're not downloading any software or anything. Just a bunch of problems. Okay, now the first one I think is pretty self-explanatory because it has the graph and everything, and you can see as x approaches 2 that the whole thing approaches negative 2. So let's start with the second one. Okay, it's the algebra, it's the algebra, it's the algebra. Okay, first thing I'm going to do is I'm going to recognize this minus sign gets applied to both terms. So, save ourselves some aggravation, put parentheses around it. Remember, I can't start hacking away until things are being multiplied. So I'll rewrite this. The limit as x goes to negative 2. And again, I can't let x equal negative 2 here because division by 0 is undefined. So my minus sign, obviously there's nothing I can do with this, but this is again a difference of perfect squares. So that factors to be x plus 2, x minus 2. And then over x plus 2. Be careful with this minus sign. Don't distribute it or anything. Just hang on to it until the end. Okay, so now I can get rid of those guys. And I have the limit as x goes to negative 2 of the negative of x minus 2. Okay, so now I don't have to worry about division by 0. So I have the negative of, I replace this with the negative 2. That gives me negative of a negative 4 equals 4. Okay? So I know, you know, if you scroll down to the, I don't know, 3rd or 4th page or whatever, it has the answers in red, but it doesn't show you how to get the answers on that CUDA software. So. But if you remember how to factor, and you're careful about when you can cancel and when you can't cancel, it makes things much, much easier. Okay. Alright, so the third one, the limit as x goes to 3 of, what was it, x squared minus 7x plus 12, x minus 3. Okay, so this is just that reverse FOIL kind of factoring. So it's going to be x minus 3x minus 4. Now remember, it doesn't matter which one of these I write first. The order of multiplication doesn't matter. 2 times 3 is the same as 3 times 4. So that doesn't matter. And down here we have this. Now I can cancel. So now I have the limit as x goes to 3 of x minus 4. Well, 3 minus 4 is negative 1. That's not too bad, right? So, I'm going to factor the bottom in this case, the denominator. Okay, so I have my x plus 3. And again, this is reverse FOIL. So it'll be x plus 3, x minus 1. Hey, helpful hint, fun fact. Okay, you know how textbooks are, and these problems are the same as you would find in any textbook. Okay, nobody likes to factor. It's one of those math words that starts with an F, like fractions and functions. Nobody likes it. Let this be your launch pad. Whatever it is that has this, just like the thing that doesn't get factored, that's probably going to be one of the factors in the part that does get factored. I don't know if that made sense. But see, I know this is probably going to cancel with something down here. So when I factor this, I'm probably going to have an x plus 3. Then you can back into the second factor. Fun fact. Okay, so you can have a 1 over x minus 1. So if I put a negative 3 in here, I'm going to have 1 over negative 3 minus 1. 1 over negative 4. Also, remember this, okay? Negative 1/2 written like this is the same thing as negative 1/2 written like this, or 1 over negative 2. Those are all equivalent. It doesn't matter where the minus sign falls. Okay, as long as there's just one, because if there's two, they do each other. Okay? So I saw yesterday on the news that Harvard is canceling all person-person classes for the entire academic year of 2020-2021. So if Harvard's doing that, what do you think Pitt's doing? We have a virtual town hall tomorrow with faculty and administration, so I'll let you know if there's anything that comes out of it. Okay, this is one of those piecewise functions, like the first one on that sheet. And this is the one, like, I think Khan Academy, Sal Khan did these as well. Okay, so for this one, as x goes to 0, doesn't actually equal 0, but it approaches 0, what does the whole function approach? Well, if I put a 0 in here, 0 plus 1 is just 1. Rocket science. Some of these are really tricky, though. Okay. Same kind of deal with problem number 6. If x is equal to 3, the whole function is equal to 2. But as it converges on the number 3, okay, when it's, 3.001 coming from that angle, or 2.999, it starts approaching this. So all you're going to do is just replace this x with a 3. So that gives us 2 plus 3 halves. Well, that's 1.5, so the whole thing is 3.5. Or if you want, you can write it as 7 halves, however you want to do it. Or you can use your calculator. There is a reason why we're learning this. I promise you. I can't wait to get to that part. I don't like these. I think they're boring. Okay. Oh, I've only received a few tests. Don't let it go too far. Okay, I like to put parentheses because I want to make sure that this is going to get applied to both terms following it. I think they have it out front in there. Okay, so again, this is a difference of squares. So I'm just going to factor it. Keep your minus sign, and this will be x plus 1, x minus 1. And remember, if you FOIL this, you're going to get that. Okay, then we have over x minus 1. Okay, so obviously if x is allowed to equal 1 here, I have division by 0, which is undefined. But once I simplify it, then I can actually get a number. So if x is 1, you're going to have minus 1 plus 1. Gives you negative 2. Okey-doke.